How's it going, everybody? I want to take a look at our next video in the FlexVPN section. And what we're going to be focusing on in this video is going to be what's known as the router client. Now, the client is going to be what's referred to in the EasyVPN world as the hardware client. The idea is you're templatizing config. So instead of having to go manually configure every connection you're going to have, you're going to use a client-based config. And then you're going to map it to every tunnel that you're going to be applying this to. And actually, it's pretty easy to work with the few times that we're going to set it up. We're going to work with that in this video, and then there's going to be some additional videos that we look at, some advancements to that, where we do like auto connect and manual connect and stuff like that. So let's go take a look at what it actually looks like before we start diving into it any deeper. We're actually going to look at this on CSR4, and what I'm going to do is I'm going to go to global config, and the first I'm going to type in is the crypto IKEv2, and then we have the client config, and then we'll call FlexVPN, and we'll call it IKEv2 client. Underneath here we have not a ton of options, right? But it's kind of like the profile, if you will, type of configuration. So we have the backup option. If we wanted to, we can set up a backup group. We could also do the client, and we can specify the interface that we want to connect. So we would say client connect, and then the tunnel number that we want to use, for example 43 in this case. We could also do the peer. The peer we're going to specify too in the sequence number. So in this particular case here, the lower number wins, so it's more preferred. So you could have multiple devices that you could point yourself towards. And we can specify, like 1.1.1.1 could be who we peer to and things like that. Then we have the connect, and then we can say connect auto, which would automatically bring the connection up and running. And then we can do other things like that. You can specify the source of who you want to peer from, and then you can say like 10, and then which particular interface you want to source traffic off of. We'll take a look at that in more of a high availability type of scenario. But what we're going to do, and it's actually pretty cool what you can do with it, is we're going to start off with the configuration where we try to move away from specifying the peer underneath the tunnel. So the idea is we're going to specify the client. We're going to connect via tunnel 43, and then we're also going to specify the connect auto, so we don't have to worry about anything. It's automatically going to come online. And then we're going to specify the peer. In this case here will be specify a sequence number of 10, for example, and then we'll specify 31.0.0.3, and then if we wanted to, we can track that particular interface based off of whatever sequence number we decide to use. So the cool thing about that is when we go to do that, we can say, okay, if we're tracking a line protocol with local connection, or if we're tracking a remote IP address, so we create an IPSLE instance first, and we're tracking the reachability of that ping or whatever the case might be, and then if that goes down, we can actually fail over automatically to another connection. It's actually pretty cool. We're not going to do any tracking right now. We're just going to do the peering. So do show run section IKEv2, and you can see underneath the client here that we are going to set the peer to be 31.0.0.3, and you can see the connect auto is the default configuration. So do show run interface tunnel 43, and what you do is underneath interface tunnel 43, we're actually going to shut it down, bring the connection down, and there we go. So now we're going to type in the command is going to be tunnel destination is going to be dynamic, and then we also have to specify that so that should be all we have to worry about, because now once we're on tunnel destination dynamic, it should fall back to the client. So do show run interface tunnel 43. What we're saying is use the client to do the peering and bring that online. So I'm actually going to type in no shut and do that. So what should end up happening is, you notice how the client, it's calling the client config, and give that a couple of seconds for it to do its thing. Oh, we have a problem of some type here. Let's CSR4 does not like the config for whatever reason. Oh, there we go. It just took it a minute. All right, so it doesn't happen right away, and it's not like super fast. I've noticed that. I forgot about that actually when I was testing this out, that it can be a little slow. So we're actually using the client config, right? So by saying that, we go out and if we do show run interface tunnel 43, we can see that we're now saying the tunnel destination is dynamic. Do show run section IKEv2. We're actually saying our peer is 31003 and client connect tunnel 43. So by typing that in, it'll automatically go out there and pull down the information that it needs to connect to the hub that it needs to peer to, and then we'll have the peering up and running. That's pretty much what is done when we go through to configure this, and it goes through and sets up. Pretty straightforward stuff for the most part, but it can be a little tricky if you've never dealt with it. So let's take a look at doing actually manual connect now. It's a little different than what we've seen before. So let's go back underneath. Let's actually shut down the tunnel. The tunnel will go down, and then we're going to go underneath the client connect, and then we'll go underneath here, and we'll type in the connect is manual, and you're going to hit the enter key on that. And then what we'll end up having to do is interface tunnel 43. We'll shut it down, or I'm sorry, no shut it, right? But we're not on connect auto anymore. So what we'll have to do, the interface itself will come online, right? But if we come to here, it goes, that's as far as it will take it. What we actually need to do is, this would actually require manual intervention. We have to type in the crypto IKEv2 client, the FlexVPN if we connect, and if we had multiple connections, we'd have to type that command in. But I'm going to do this, and then it pops up. So it popped up right away for us. We have an EIGRP adjacency, and everything is good. So that's how you do the manual connect. Pretty simple. Show run section IKEv2, and we decided to connect manual. And because we had everything already squared away underneath the profile, it popped up right away. We're able to get it up and running without really much of a hassle of any type in order to get it to become operational. That's pretty much what you'd want. That's the client. That's the connect auto and connect manual. Now, one of the things you've seen me do multiple times already is use EIGRP. But what happens if you can't use EIGRP? No dynamic routing is available. So one thing you can do is, if we were to go look at the show run section EIGRP, if we were to take and let's say we want to exchange routing, but we can't use a dynamic routing protocol for whatever reason. So one thing you can do is called the IKEv2 route exchange, or the config exchange. So what I can do is, I'm actually already doing this. If you look up here at the top, we have this authorization profile, which is, I think it's hiding on me at the moment, show run section IKEv2. The authorization profile. We're calling it right here, actually. Yeah, but the idea is, you want to be able to send traffic. You want to be able to use IKEv2 config exchange to send traffic back and forth between the nodes that you want it to communicate with, right? Well, in order for this to work, you need it to be able to send this information. So what you can do is, you can actually set it up to send information. So we're actually already doing that on CSR3 side. If we come over here and do a show IP route static, we are actually learning static routes from the remote ends. So if we were to do virtual access 3 is now up. Virtual access 3 is right here. So what we're actually doing is on the CSR4 side, if we do a show run AAA, and we do a show run all section IKEv2, down here at the very top, we can see this crypto IKEv2 authorization profile right here. We are actually, so actually on this side here, my mistake. So show run section IKEv2. Right here, we're actually modifying the default, or actually we created our own policy. But what we're saying is, go ahead and post the information. The idea that we want to do, actually 4 isn't showing it up. Route set interface. What is going to happen is CSR4 is supposed to send its information up to CSR3, so that CSR3 knows where to send the traffic. And what ends up happening is CSR3 receives the information inbound and then knows to set the loopback address. And so the loopback address is set. So CSR3 knows that if we look at access 3, 10.1.100.66, if we look on this guy, show IP interface brief, we can see that this interface right here, whatever the IP address of the tunnel gets is what the virtual access tunnel gets. So we know if we wanted to do anything like, for example, IBGP, we'd be able to do it. And that's how we're able to pull it off, is through that connectivity. So what we're going to do is, if I wanted to, I could actually elevate that a little bit. I can go to the config exchange and show run section IKEv2. It doesn't show up here because it's basically not configured to do anything by default, even though we're calling the default one right here. I can create an access list, and I can say, you know what, let's do show run section EIGRP, and underneath here we're going to basically say, you know what, I don't want to send any data. Whoops. I don't want to learn EIGRP over the tunnel, right? So we're going to lose our EIGRP adjacency and all that good stuff. So now what I'm going to go do is I'm still going to form my peering, right? That's still going to happen regardless. But instead of me propagating my local prefix, I'm going to type in IP access list, and I'm going to say extended, and I'm going to say permit, or it's going to be IKEv2 config exchange. I'm going to say permit IP of 10. From any source. Or I am the source. So permit the 10.4.8.0 0.0.0.255 any. And what I'm going to do is do show run all section IKEv2. And underneath this guy right here, since we're calling it already, we're going to go ahead and say route set, and then access list, and then the ACL name we just typed in is going to be IKEv2 config exchange. So we're going to do that. And CSR3 is already, if we go ahead and do a debug crypto IKEv2, we go back to CSR4. Now that we've added that in, when we go to do show IP interface brief, when we go to bounce tunnel 43, interface tunnel 43, we shut it down, right? The actual connection itself goes down. And then we're going to say no shut, bring it back online. And if we come back over here, what we should do is once it comes back online, which will take it a couple seconds, it won't be the fastest game in town by any stretch of the imagination. Once it comes back online, what we should get is a config exchange entry. Let's give that a couple seconds to do its thing. I'm actually going to pause the video until that comes back online. Alright, so I kind of shot myself in the foot, but it took me a couple seconds to realize what the problem was. Remember, we had to do that crypto IKEv2 client FlexVPN connect. So we have to remember, we have to type that in. because we have it set to mode of the connect manual. So when we do that, then it pops up. So then we get that connectivity up in play. So we come back over here, and so we should get a IP2 config exchange. Here, let's give that a couple seconds to finish its thing. What will end up happening is we will get a ACL that will be configured for traffic on the back end. So let's do an undebug all. Let's scroll up here real quick, and I'll find that config exchange. Let's see. This is the very beginning of it, so it's somewhere in here. Oh, can I do a control find? Find. Let's start from the top here and work our way down. Instead of trying to figure it out, we'll go direction down, we'll do a config. Find next. Oh, it did the entire connection. Oh, never mind. We'll go up, but we'll start from the bottom. We'll do a find next. Oh, cancel. Okay, well that's not exactly the way I was hoping it would work. So let me see if I can't find it real quick. Assuming I'm doing everything correctly. I just don't know where it'll be. Worst case scenario, you know what I can do? You just grab all this information right here. And grab that. And then I'll do Notepad. I'll paste this in here. And I will do a control find here and do a config. Let's start at the top and work our way down. Say next. Oh, look, it's spell config, right? Find config. Okay. Well, the way this should work. Config request right there. Config reply. This is it getting its IP address on the remote end, right? So that's CSR4 getting an IP address. And then we come down a little bit further. That's the IPsec coming online. And config set, config mode data. Yeah, so I don't see it in there, so I'm gonna leave it be. But that's basically how that came into play. So you know what, actually, I might have to switch that up. So let me go take a look at that in a little more detail. So our next topic we're going to be taking a look at is going to be the config exchange option, where we're actually going to be using the exchange information capability built into IKE version 2 to allow CSR4 to propagate information to CSR3 through IKEv2 config exchange. The configuration is actually pretty simple. Right now, if we do a show IP route static, we don't really have anything going on inside of here. So what we need to do is actually, let's do a clear IP route star, and so what'll end up happening is show crypto IKEv2 SA. Let me go ahead and clear crypto IKEv2 SA, and then clear clear IPsec IP2 SA local address. There we go. No, remote address. Remote, because I don't want to take down everything. I want to just take down the local one, the one that going to router 4. So I actually want to break that, get rid of all of its information. So what'll end up happening now, if I do a show crypto IP2SA, there it goes down. If I do a show IP route, I shouldn't see any routes from CSR4, which I don't. So what I'm going to go do is on CSR4, we took down the tunnel, right? The show crypto IP2SA, we have nothing up. So what I'm going to go do is I'm going to create an access list on CSR4 to push the information from CSR4 up to the CSR3. So basically, instead of doing a dynamic routing protocol, which may not be possible, we're going to do a configuration where we're going to push the local prefix over. So the way we do that is go to global config, IP access list standard, and we're going to call this IP2 config exchange. I'm going to type in permit 10.4.8.0 0.0.0.255, and then what I'll do is a crypto IP2 authorization and policy is going to be default, because there is a default one we're using currently. We're going to set, it's going to be route and then set. We're going to say access list, and then we're going to call the access list name of IP2 config exchange. We're going to do that. Now what will end up happening is the 10.4.8.0/24 config exchange will get sent up to CSR3. So what I'm going to go do is I'm going to interface tunnel 43, which should be up at the moment. We're going to type in shutdown, take it down. Give that a second to trigger. So we're going to type in no shut. So the tunnel interface itself will come up, but do show run section IKEv2. Right now, underneath the client that we have configured, it's set to manual. So we have to jump out of global config and hit the up arrow a couple times and type in the command crypto IP2 client FlexVPN connect. So that'll allow it to connect. The line protocol comes up and we actually get the connection to go across. And we go over here to CSR3, give this a couple of seconds to propagate. What'll end up happening is as soon as this is done, it doesn't happen. It's not super fast either, so you'll have to give it a couple of seconds to show up. What'll end up happening is it'll be config exchange, which is right there in front of us. So give that a couple seconds, and there it's done. I'm going to undebug all. What'll end up happening is you'll see right here that we see the 10.4.8.0/24 prefix come across the wire. If we do or show IP route static, we can see that there is a static route to that particular prefix, and there is a static route to the loopback address of CSR4. And that's exactly what we're expecting to see. And that's how you know everything's working the way that it needs to. There's another way of doing this on the CSR3 side, where if you needed to do multiple prefixes, the best way to do that is via the ACL. So I could do the same thing over here on CSR3. Do show run section IKEv2. We can see that in this proposal here, we come underneath this guy. We can come underneath here and type in route and say set. We can specify the local parameter. We can say IPv4, and we can type in 172.16.1.0 with a /24 mask. And I don't believe this supports multiple inputs. So if we were to type in, for example, if we were to do show run section IKEv2, we would see that that particular entry is there now. If we were to type in route set and then local and then remote, or is it? I'm sorry, it's actually not that. Let me go and fix that real quick. Type in no and pull this out, because we're not setting a local route. We want to set to what's going to be here available locally. We want to make sure that we're sending this traffic across the wire so it's remote. So it's going to be route, set, and remote, and then the IPv4 traffic, and we'll set this particular prefix right here across and send it. and then do show run section IKEv2. That is there now, and it will say route set remote IPv4 of 10.1.0.0/24, or sorry, /16. Do show run section IKEv2, and the last time I checked, okay, it does look like it'll send it. So what I'll do is on the CSR4 side, if I show IP route, like I don't see anything coming across the wire from the other side, right? I don't see the 172.16.1 network. I don't see the 10.1.0. So what I'm going to go do is I'm going to go bounce that connection. So interface tunnel 43, I'm going to shut it down. And so that'll take the tunnel down, and I'll go ahead and no shut it. It'll take a couple of seconds for that to trigger. So then I'm going to come jump out of global config, and then I'll hit the up arrow a couple times and do this. That'll bring that up, and then once the connection comes online, on CSR3 side, we should see that, I don't remember turning the debug off, but it looks like it's working. Do show IP route static. We can see the prefixes in the routing table, and we go back to 4, and we hit the up arrow. We should have a couple of static routes. We'll have the 10.1.0.0/16 prefix right there, and we'll also have the 172.16.1.0. The benefit to this is we have reachability with no need to have a dynamic routing protocol. So you can run EIGRP, you can run BGP, you can run pretty much whatever you want. The beautiful thing about it here is it's a static route. It's embedded in the connectivity. So if I wanted to go out and reach something, I could. The cool thing about it is with the route exchange, you can be as broad as you'd like. So that's the cool thing about it, right? You'd be able to propagate as much information as you need and stuff like that. So that's pretty much it for that. There is some additional stuff that I want to test out, but I'm going to wait to do the source interface tracking and stuff like that until we get into the single hub and the dual hub configs for doing the high availability, because when we start doing that, it'll make more sense to have the failover features in play and stuff like that. So we'll be able to track more things and stuff like that. It'll make it just slightly more interesting. The typical thing that we would want to do is I would need more than one local interface. So that means that I had to go out and either add another router that'll act as another internet. So for example, here I could add like another router here and then connect 4 and 5 and whoever else to that, and then do the tracking that way and go from there. But for right now, that's as far as I need to take it. So until next time, guys, thanks so much for stopping by and hanging out with me. We'll catch you guys in the next one.